Hello and welcome back. I'm going to wrap up chapter 18 with video 7. This is going to be part C. We're going to focus on putting everything together in this video. So in video 7b, I went through the two types of nucleophilic aromatic substitution reactions on aryl halides that you need to know about. And now we're going to practice putting together synthesis schemes that can involve both types of reactions. So we spent the first part of the chapter talking about electrophilic aromatic substitution reactions. And then in my last video, I went over the nucleophilic aromatic substitution reactions. And after getting through this video, you can practice on these problems from the chapter 18 problem set. So picking up with where we left off, we're going to sort of put all of this together now. So here's an example of a synthesis problem. I want to make this where I have a hydroxyl group and an amino group para to each other on a benzene ring. We want to make this from benzene. So for this, what I'm going to try to do is try to brainstorm out loud a little bit. When you first start practicing these synthesis problems, it might take you 10 minutes. The more you practice, the faster that you are going to get, just like with the NMR problems. So let's just start off and brainstorm a little bit out loud. So when I see the OH group on the benzene ring, I know that I can't do that. I can't directly put an OH group on a benzene ring using electrophilic aromatic substitution reactions. So I must be using a nucleophilic aromatic substitution. So let's see, I'm gonna just, maybe I'll put my notes in, it doesn't matter what color I put it in. So we need an NAS, nucleophilic aromatic substitution reaction to get this group on, okay? Now, in order to get the NH2 group on the ring, we could potentially do that by nucleophilic aromatic substitution, as you saw examples of that in video 7b. But the trick with that one is that we needed to do that ortho to a halide. So we also know how to get an amino group on a ring indirectly using EAS, electrophilic aromatic substitution, where I put on a nitro group and then I can reduce it, right? So that we have to think about which way that we're going to do that. Now I can right away eliminate doing this by the nucleophilic aromatic substitution with the type 2 aryl halide, because we're not going to have a halogen ortho to the what ends up being the amino group. So I'm going to make a note here that I want to put this on by electrophilic aromatic substitution by first doing the nitro group, and then I do my reduction to the amino group. Okay. All right. So let's go ahead and let's see if we can get started on this. So I know for nucleophilic aromatic substitution, that means that I need an aryl halide. I know how to make an aryl halide like this, right? Using electrophilic aromatic substitution from benzene, right? This is the halogenation, okay? And again, I don't have to have it be a chlorobenzene. It could be the bromobenzene, but I'm just gonna, since I wrote down chloro, let's do that. So if I start from benzene, and I want to halogenate it, so I'm going to use Cl2, and I can do this with FeCl3. If you want to use the aluminum chloride, that's fine too. So just a reminder, this is from the electrophilic aromatic substitution. This is the halogenation reaction you learned. Okay, and so I'm getting my chloro group on the ring. So remember, I need that in order to do the nucleophilic aromatic substitution reaction to get that, to replace this. Now, before we move on, let's remember here that we also have to get this piece on, right? And so I can do that by the electrophilic aromatic substitution reaction. So chlorobenzene, the halogens we know are going to be weakly deactivating but orthopara directing. So I'm just going to make sure I make a note of that. And so if I carry out in the next step a nitration, so HNO3, H2SO4, so this is another EAS, nitration. I expect then, since this is an orthopara director, that I can get a nitro group at the para position, since this is an orthopara director. And remember that the para is usually the major product. So I'm going to go ahead and do this. And now I have my nitro group at para to the chloro group. Okay. And now what I can do is I have an aryl halide with an electron withdrawing group, in this case at the para position, so it can serve as an electron reservoir for our nucleophilic aromatic substitution reaction with a type 1 aryl halide, right? Because it has this electron withdrawing group para. So we could do this if the electron withdrawing group is para or ortho, but not meta. Okay, because we want to replace this with an OH group. So what am I going to use for that? So I can use sodium hydroxide and water. Okay. And when I do that, I'm going to substitute the chlorine for the OH group, okay? And then I can reduce this to an amino group. So I had, and I'm sorry, I labeled this one here. And now we have our reduction using the hydrogen and palladium on charcoal. If you want to use Klein's reagents, that's fine. It's just on an exam, this is what I'll provide for you. And if you're stressing out about like, oh, how did you know to include the water here? I just wanted to make sure that this was protonated. Don't stress out about this. If I give this to you on an exam, I'll include it. And I'm not going to try to trick you with putting in something that wouldn't work. Okay. All right. So that's kind of how you start. So that took almost 10 minutes, right? And you're going to practice this a whole bunch so that you get faster and faster at it. So let's try another example. So let's try to get an ethoxide group as well as a nitro group on the ring, and the chloro group as well. So when I see this ethoxide group, I know that I need to do a nucleophilic aromatic substitution reaction to do that. And I see that this happens to be ortho to the chloro group, right? So what I'm going to do is I'm going to pause the video so that you can stop and brainstorm, and then we'll come back and we'll see what you came up with. So before, I'll let you do some brainstorming on this, and then we'll come back together. Pause the video now. Okay, so hopefully you've had time to just kind of make some notes. I just jotted down some notes here. So again, I know I'm going to put on this piece via nucleophilic aromatic substitution. That means that I have to have an aryl halide. I'm going to be substituting the halide for this piece here. And to do that, so that's the type 1 aryl halide that we need. And I need an electron withdrawing group for that, either ortho or para. And so notice that we've got this nitro group here, para, that is a good electron reservoir. So I'm going to need this on before I put this piece on. And before this piece is on, I'm going to have a halogen here, right? Now, if we look at, we've got these two pieces here. Who is going to go on first and second? So if we, because this group here is that meta directing, so if I put on the nitro group first and then I go to add the halogen, I'm going to have it be meta directing. Well, I need a halogen at this position, which is para. So I'm not going to put this piece on first. So I'm going to start with this. So from my benzene ring, I'm going to go ahead and do my halogenation. You can do it with bromine or chlorine, doesn't matter. And get that chloro group on the ring. I'm going to, why don't I just, I'm going to put it here just to start. So take this and rotate it. Okay, and then if I do my nitration next, so remember that this is not going to be this. I'm going to have the chlorine where I'm going to eventually put this piece. So we have weakly deactivating, ortho-para directing, para being the major product. So now when I do my nitration, I get my nitro group here. So remember, this is going to serve as an electron dumping ground for my nucleophilic aromatic substitution. So this was, use again red here, this was EAS halogenation. And then we had another EAS nitration. And now aryl halide, electron withdrawing group, para to it. Oops, what did I just do here? Alicia, my gosh. Let's fix this, sorry. Getting excited because these are so much fun. Here we go. It's like, what is wrong? Okay, now we're gonna do our nucleophilic aromatic substitution. My nucleophile needs to have ethoxide in it. Do I care if you use sodium or potassium ethoxide? No, I don't. Let's just use sodium. And the solvent that we'll do this in will just be, and this, since this is ethoxide, we'll do this in ethanol. Don't panic, I won't try to trick you by giving you the wrong solvent on an exam, because you had to, this is from, 301, so I'll assume that you're good on that. Okay, so now what are we doing? So now we are substituting this chloro group for the ethoxide group, thanks to having this electron withdrawing group, para. Okay, and now what do we need to do? So now I need to have a chlorine at this position. So let's think about this. This is strongly deactivating, meta directing. What about this piece here? So I'm just going to put in a vote for a meta. Doesn't matter which side I put in, there's a vote for the meta from this. What do we know then about this piece here? The alkoxy piece is moderately activating and ortho-para directing. Okay. Well, the para position is taken, so I can't vote for it. So I just have the ortho available. So they're both in agreement with one another. I don't have to rank these. So now I'm going to carry out my halogenation, FeCl3. If you want to use aluminum chloride instead as the catalyst, that's fine. And then we get our product and we're done. So voila. Okay. So you are going to go practice lots and lots of this. And this will be the end of chapter 18 material. We'll start chapter 19 next week.